we got the radioactive element, which immediately puts me off as a non-scientist, non-mechanics person, has a half-life of 29 years. Find what percentage of the initial amount of radioactive strontium is left after 100 years. Okay. Is the amount of radioactivity going up or going down over time? Down. Yes, it's decaying as a half-life. So here, if we say, let the radioactivity be R, then the radioactivity over time is going down. So I need a minus sign in there. And actually what we have here is that the radioactivity itself, or rather the change in the radioactivity here, is proportional to how much is there at any one time. It's just like the last question to a certain extent. So over here it's going to be minus KR. That's a differential equation that you get. It's going down in proportion to its size. So, like before, separate the variables and integrate. Keep the r's on that side because there's a dr on the top of the fraction, which means this r comes over here. Just like last question really, keep the k there, no need to move it. Stick the t over there. Separate, integrate. Identical to the start of the last question really. So, last time we had this, we said that was log of that letter. Over here we said that was minus k t plus c. Okay, we got to there last time. Right, we want r, anti-log it like last time. Use the same trick as last time. If you want to, you can think of that like that. We can let e to the c be equal to a, so I can rewrite that like that. That is basically a repeat of the question from last time. Okay. Right, now we need to do some substituting in. In the question it says a half-life of 29 years. And we want to know what percentage of the initial amount is left after 100 years. So, the initial amount. What does it say the initial amount is in this question? No. The 90 there is just part of the substance's name. It doesn't actually tell us what the initial amount is. So the various things you can do, you can make up a number if you want and just put it in. There are other things you can do, and I'm going to show you something else in a minute. But the way the model solution to this question was let's say the initial amount of radioactivity, let's call it R0. And that will be when time is 0. So they said let the initial amount be R0 when time is 0. And if you substitute that in your equation, you get R0 equals a e to the minus k times by 0. And we said before, e to the 0 is just 1, so that tells you that a is the same as R0, the initial amount of radioactivity there. Which means that formula becomes R equals R0 e to the minus kt. This is just following the same pattern that we did last time. Okay. Then, this half-life thing. What do we know then? If it's got a half-life, what other information can we substitute in? A half-life of 29 years. I want to say something about T and something about R.
R29.
R equals half-life.
Oh yeah, R, half-life means after one half-life, which is 29 years' time, you two, come here please, after 29 years' time, the amount of radioactivity will be half of what it was to start with. Okay? 29 years' time, the amount of radioactivity will be half of what it was to start with. Substitute that in, I get R equals, sorry, I don't get that at all, I get R is half R0, equals R0 e to the minus k times by 29. Then, if you move things around, if I bring that r0 down over here and divide by it, I get that. What's the left hand side of that equal to? Half. Yep. Okay. Left hand side of that is equal to half. The right hand side is e to the minus 29k. I want to find out what k is. What would it be good to do?
Log.
Take logs. So log of a half. Log of this just gets rid of the e. It's minus 29k. So k will be log of a half divided by minus 29. And if you do it on a calculator, you get, well, I haven't actually worked it out. Here's a decimal. I've just left it as that. But log of a half, is there another way of writing log of a half? A nicer way of writing log of a half.
1 take away from 2.
Sorry? Log of?
1 take away from 2.
Yeah. Using the laws of logs, okay, if you have got, what we have done there, if you've got log of a divided by b, that's the same as log of a minus log of b. So using it here, log of 1 divided by 2 is log of 1 minus log of 2. What is log of 1? 0. Yeah. So that is 0. 0 minus log of 2. So that's actually just minus log of 2 divided by minus 29. 2 minuses cancel. So that's just log of 2 over 29. That's what k is. Going back to the formula I had earlier, I had r0 e to the minus k t. So that's my new formula, substituting it in. And now what I've got to do, if I find the question again, is find out what the radioactivity will be after 100 years. So now if I let t be 100, substitute that in there. I'm having a think here. Have I got something? No, that's right, that's right. Keep that in there. Change that t to be 100. And then work that out on a calculator. Did anybody get this far and do it this way and get that done on a calculator? Okay, I can tell you what it will be. It will be 0.0916. And that is being times by RO. That is telling you in 100 years' time you have 0.916 of the initial amount. So when the question was saying what percentage is left, turn that into a percentage, you get 9.16%. That is exactly the way that this model solution had that answer. And I will go through and show you the marking, and then I will show you a different way of doing that question. It'll be on the KLP later on, Sam, if you haven't got it all down now, okay? So, going through this way, following on from last time, I gave 1 mark for the differential equation up at the top. I gave a mark for separating a variable, so now we're on 2 marks. For doing an integration there, I gave 3 marks. For getting down to that line there, I gave 4 marks. For substituting in at this point here, I gave another mark for getting down to what k was equal to. Where have I got what k is equal to? Over here, that was then 6 marks, following the mark scheme from before. That was then worth 7 marks. From getting that value there was 8 marks, and that was 9 marks. That was why it was a 9-mark question.
Sorry, how much was it up to getting what k equals?
K equals 6 marks.
I didn't get that simplified version though.
Okay.
I just got ln of a half.
If you got that version there, it's the same thing, so you can have your 6 marks for there. That's fine. But I consider that to be an exceptionally stupid way of doing that question.
And the previous one.
And the previous, yes, you're quite right, and the previous one as well. It's a bit more obvious for this one. You can do this question like this, okay? Here we go. If I can find the question again. And then in a minute we're going to pick Mr. Powell's brain and just ask for his comments on this as well. There's the question, okay? It's talking about half-lives. If it talks about half-life, after 1 period of time, it's a half of what it was. After 2 half-lives, it's that much of what it originally was. After 3 half-lives, it's that much of what it originally was. After 4 half-lives, it's that much of what it originally was. How many half-lives are we interested in this question? We're interested in 100 years, and a half-life is 29 years. How many half-lives are we interested in?
3.4483.
Where do you get your 3.4 number from, Sam?
100 plus 29.
Yeah. If we do that calculation, that will tell us how many half-lives we are interested in. So all you need to do to get the answer for this question is do a half to that power. If you do a half to that power, you get that number straight out. That is the 3 thing that Sam said. So there's your answer, 9.16%. And that's all you had to do in that question. So therefore, that has to be worth 9 marks. So if you did it that way, absolutely fine. Okay, and I know that Tom did, and it's much easier. Mr. Powell, any comments on that and mark schemes you've looked at and things?
I love that. I mean, it's just classic proportional reasoning. I do half-lives just by starting with the fact it's a half-life.
Do you want to come and
show you? Sorry. Essentially, this is about half. This is a halfway house, ironically, between the two, where I know that half-life means I start with an assumption. I'll start with a kilogram because I don't actually know how much. So
if you remember when I said, do we know how much it is? I actually said you can just stick a number in there if you want to. I did it the way that model answer did, but this is a better way than the model answer. It's not as good as what I showed you, but this is better. Just stick a number in there that's easy to deal with, like 1.
1, the ultimate easy number.
Just to make life easy.
Yeah, so if you've got 1 kilogram to start with, I know after 29 years it'll be down to, I have to have a KT in there. Oh no, T is 29, isn't it? So after 29 years, I'm down to half a kilogram. And so then I just solved that equation to get K. So in a fairly sort of lengthy way down here, I get a negative K, and Mr. White was saying we know it's going downhill, so we know it'll be a negative power, but my K there comes out as negative here because I've got the ln 0.5 in here, so I get K as minus 0.0239, and then I can put that in, and in the textbook they use Q and Q0 for all these exponential problems. Remember from chapter 3, they're very hot on that. So quantity that we're interested in, starting quantity Q0, and I know this is my model for strontium 90 is e to the minus 0.0239t, snap in 100, you get that. It's not sufficient as just proportionally working with the half-life, but it's a bit faster than working it through all the way.
I think the key question is that from looking at past papers, if they did that, that's absolutely fine.
Yeah.
It gets the answer. Absolutely fine. Okay.
I did think when Mr. White mentioned it that it was part, because we're both obsessed with Cold War programs at the moment. Strontium 90 was big in the Cold War. It was one of the radioactive isotopes that come out of atom bombs that people were scared of because it gets into your teeth really, really quickly, and so it's why people after a nuclear war, everybody's teeth are going to start falling out very quickly if they go anywhere near the fallout. Anybody use Sensodyne toothpaste? Apparently, you're probably all too young to have sensitive teeth, aren't you? But if you look on Sensodyne toothpaste ingredients, and there's one of them that doesn't, it has some hexafluoride thing, but most of them you see in there, it's got strontium in the ingredients. Yeah. And I have a friend, one of my best friends in uni, he's head of medical physics in Manchester now, and he was saying there's no such thing as non-radioactive strontium. And it's in the Sensodyne because they know Sensodyne says it gets into the teeth. I don't think it's as dangerous as strontium 90. It must be some other isotope of strontium.
Perhaps I'll just stop the video here before they see it and start suing you, Mr. Powell, on